This video is about the BeoLoverRPM device. For more information, please visit our blog at beolover.blogspot.com or go to the website at beolover.com. The BeoloverRPM device allows to adjust the RPM of your Beogram precisely. It's also very useful to log the RPM over time. That allows the detection of intermittent RPM changes. Okay, let me show you first how to use the BeoloverRPM for a quick RPM calibration of your Beogram. So the first step is to start the turntable and then place the BeoloverRPM device next to the rotating platter. Make sure that the red triangle points towards the center of the platter, then plug it in. And now it starts up, and it takes a few seconds until it calibrates the measurement. And here we go. It shows now that the RPM is a little bit too fast in this case. And so you can use the dial on the RPM panel to reduce the speed. And so here we go, the RPM has been calibrated. Let's discuss real quick how this works. So the sensor on the BeoloverRPM has an infrared LED that emits infrared light and an infrared diode that receives infrared light. And so if you look at the sensor from the bottom, you can see that here. So the dark item here, that's the diode, and the transparent one, that's the LED. Now, so the LED sends out the light, and as the platter spins here, the light is well reflected from the blank aluminum surface, and whenever a rip comes through, the light reflection is reduced. And so the infrared diode over time measures an intensity profile that looks like this here as the platter spins. So every time a rip comes through, then the intensity dips, and the microcontroller that is inside the BeoloverRPM is able to measure this intensity, and then it can determine the time it takes from one dark event to the next. And so if you do the math, 75 milliseconds between these events corresponds to a 33 RPM settings. And so this is how the BeoloverRPM determines the RPM of the platter. Okay, let me show you a few more tricks that the BeoloverRPM has up its sleeve. But first, let's convert it that we can mount it on the frame of a Beogram. And so for this, it comes with these two frame adapters, one labeled W, the other N. And W and N, that refers to the spacing between these legs that the frame adapters have. So wide means a little larger spacing than N for narrow. Anyway, so let's mount one of them that fits on the Beogram that I'm using here for this video. And so on the bottom of the BeoloverRPM, you see these two mounting holes. They line up with the holes that are in these frame adapters. And so all we need to do now is mount the one that we need to the BeoloverRPM with these two bolts and a 2mm hex driver. And so here you have it. The BeoloverRPM is now configured to be frame mounted. Okay, now let's put it on the frame of this Beogram. In case you wonder how one gets these aluminum panels off that are around the platter, I have a couple videos that show this in detail. One is the installation of the Commander remote control system, and the other one is my packaging video for Beograms. But anyway, so once the panels are off, here there is this enclosure wall, and so the modified BeoloverRPM now just fits on here. So you just basically stick it on, and that's it. With the BeoloverRPM installed and the aluminum panels off, it is a perfect moment to show you how to calibrate the master RPM trimmers on the PCB. You see each of the control circuits for 33 and 45 RPM, they have two trimmers in them that allow to control the RPM. One trimmer is in the RPM panel above the keypad, and the other trimmer is on the PCB. So the purpose of this setup is that we have one trimmer, the one on the PCB here, which I labeled the master RPM trimmer, that allows us to calibrate this scale here, that we have the nominal RPM, in this case 33.33, at the 0 setting of this trimmer. Because the purpose of these trimmers really is to give the user the ability to change the pitch by minus to plus 3% of the nominal RPM. So if we want this scale here to be true, we need to adjust this second master RPM trimmer that's on the PCB in a way that we get the nominal RPM when this here is set to 0. So the procedure is to set this to 0 and then adjust this trimmer using the BeoloverRPM. Okay, let's do it. So here we see the secondary RPM trimmer is not at 0, so we need to adjust this first. Very nice, at 0. And now we can adjust the trimmer on the PCB until we get 33.33. And that's it. I'm sure by now you are dying to know what these two buttons are doing that the redesigned BeoloverRPM is featuring. Here you see them magnified. Basically they allow to select between two different data acquisition modes. And one is labeled slow, the other is labeled fast. So basically the slow one gives you a data point every second or every 10 seconds. And the fast one gives you a data point every time a rib goes under the sensor. So what I've presented so far in this video was all done with the slow mode. So this is no doubt the most important mode, because you can simply use it for adjusting the RPM, and also it's very good for detecting sudden RPM changes that once in a while occur in, unfortunately, many of these Beograms, as long as the motors haven't been restored. It's also the mode that comes automatically on when you plug in the USB cord. Now the fast mode here is interesting for detecting where the noise is coming from in the measured RPM spectra. So if you look here at this graph that's produced when the fast mode is on, so the fast mode basically plots each data point in a rolling display. So you can always see the last 64 data points that occurred as the platter is spinning. What you see here is actually pretty interesting, because you see a pattern that is repeating itself, and when one looks closer into it, it turns actually out that the pattern repeats every 24 points, which corresponds to the number of ribs that are on the platter. And so this led me to the conclusion that what we see here are actually minute differences in the spacing between the ribs around the platter. Now these differences are small. If you look at the minimum, it's just 33.3 and the maximum is 33.35, so this is about 0.1% change between the slowest and the fastest measurement here. So these mechanical tolerances between the ribs are pretty small, but they're there, and it turns actually out that each platter that you do this measurement on has a different pattern. So all these platters basically have a fingerprint depending on their minute differences in the rib spacing. So I thought it would be interesting to have this mode. part of the reason is because the microcontroller that I'm using here is fast enough that it can measure accurately and refresh this display at the same time. But I think it's also always interesting to see how your data looks in its raw shape and not just look at some numbers that come out of a process. So let's use this fast mode and let's see how it really looks like as the data comes in. So all you need to do is press fast and then you get the curves. And here we have the repeating pattern. And press slow again and back into the normal mode. I mentioned already a few times in this video that the BeoloverRPM can be used to log the RPM for extended periods of time. It does that by sending the RPM not only to its little display, but also via the USB cord to the serial port where you plug it in on your computer. And so with pretty much any terminal program that you may have already on your computer, I'm using here something for the Macintosh called WCH Serial Port. It's a free little program that you can get from the App Store. And so with software like this, you can basically record all the RPM values that are being measured. So in the slow mode, it bangs out a data point every 10 seconds. And more quickly if there is a rapid change. So if you have one of those motors that produce rapid and occasional intermittent RPM changes, then you won't miss out on measuring those, because the BeoloverRPM detects that there is something going on, and then it puts out data points much more quickly. So for those periods of action, you get actually a much more rapid succession of data points. So here in this graph, that's a good motor that I restored. So you see a nice smooth line that has that noise on there that we know now is coming mainly from little differences in the rib spacing on the platter. Now in fast mode, you will also get data points, just many more, because now it will put out a RPM reading onto the serial port every time a rib passes under the sensor. So you get a lot of data points very quickly. When I saw these patterns coming out of the fast mode for the first time, I of course was quite excited about it. And so I measured here a little bit a longer curve, and this, what you see here, is basically the output that the fast mode puts into the serial port of the computer, and I just plot this here with some graphing software. And if you would count those peaks, you would see it's about 60, and so this means this is about 60 turns of the platter. And what we see here beautifully is how an analog control system is trying to stay around a set point. For this, we need to appreciate that this video was made with a Beogram 4004 that I had on the bench at this point. And these 4004s, they have a brushed DC motor to drive the platter, and the only way to keep these motors run at a constant RPM is to use a feedback process. And so these motors, they have pickup coils built in, and these pickup coils feed a little current into the circuit, and the circuit determines the frequency of this current, the ups and downs of it. And with that, then it increases the motor voltage to make it go faster when it's too slow, and then when it's too fast, then it basically reduces the voltage and the motor gets slower. And so we get this kind of up and down waving around the set point. It's actually a very similar process if you think of it like when you drive down the freeway. and you try to stay in the lane with your car. So your eyes basically see where you are, and then basically your brain tells your hands to turn the steering wheel a little bit left, a little bit right. And so you kind of go from one side of the lane to the other and stay in it, but you wiggle around a little bit. And so this is also an analog feedback process that's going on in your body. Anyway, I thought let's have a little bit more fun with the fast mode here. If you liked what you saw in this video, you can get your own BeoloverRPM. It comes with the 2 frame adapters for wide and narrow frame walls and a micro USB cable, so you can hook it up to your laptop or computer to get those long-term RPM measurements. Just get in touch via the blog and use the contact form or the email that's posted in the page header. This concludes my video about the redesigned BeoloverRPM. I hope you enjoyed it. Thanks for watching.